Okay, so today's meetup is about decentralizing gasless transactions, and the reason or what gasless transactions or meta transactions are trying to do. They are trying to solve the problem of usability on especially for the new users, or at least this was the pitch for meta transactions back in the day. So they want to help new users to onboard and interact easier with dApps or with smart contracts, because so usually new users have no ETH in their wallet, therefore they cannot pay the gas. So that means they have a higher barrier to entry. That means that they have to go through an on-ramp, register to an exchange, do the KYC process, link a bank account, deposit money, and then withdraw that whatever ETH they need to interact with the smart contract to their wallet. And all this process is meant to be shortened and eased by the fact that you would offer meta transactions on your dApp. And even so, even advanced users, I would say, I think this is the second problem that is people do not talk often about. Even advanced users have the situation where they simply have no ETH in the wallet, and maybe they do not want to transfer ETH from their main wallet where they hold, I don't know, large amounts, 1 ETH, 2 ETH, 10 ETH, or whatever they have, in order to interact with a smart contract. So in some cases, they might want to use meta transactions. So for example, imagine you get an airdrop and you have no ETH in the wallet where you received the airdrop. You would need ETH to pay for gas to claim the airdrop tokens. And or another, let's say you have rewards on synthetics and you want to claim your collect your staked rewards from there, and again you need ETH and whatever other normal contract interaction. Another reason why you would probably do not want to do that, to move to a simple tryout wallet, is just because of privacy, because you do not want to link your main account with all your funds in there to the smaller account that you're just that would be a burn or throwaway account. Yeah, so the conclusion, either you're a new or experienced developer, you might have problems just because you don't have ETH in your wallet. Yeah. So who can, or what's the solution? So that's why gasless transactions or meta transactions have appeared in Ethereum ecosystem in the scene, because they thought that it's a good way to onboard or to lower the barrier of to entry for new users. That one and high gas prices and all the other things that that kept users away from Ethereum until now. So, and who can do this? That's dApp developer. So basically, as a dApp developer, you can choose to make meta transactions available to your users, and this way you would ease the annoyance for situations where people do not have ETH in their wallet and they do not intend to transfer to that wallet. Meta transactions themselves are what they are doing. They are separating the signer from the gas payer. So this is a kind of so imagine that the user would sign a transaction. It will send it to an operator, let's call it an operator, or the way we'll call it later more technically correct, relay server, and that the relay server would pay for the gas to push the transaction to the Ethereum blockchain. So that's basically the way meta transactions work. They separate the signer from the gas payer. And then the question is at what cost? So in the end, someone has to pay for that transaction. So who does that? And the good thing is that this is programmable, at least in the way that we'll present it today. For example, you as a DApp developer, you want to pay the gas fee for your users in exchange for other tokens. Let's say your users do not have ETH in their wallet, but they have some USDC or DAI or whatever other stablecoin, and you want to allow them this option to pay with one of the tokens that they hold in their wallet. Another thing, if you really want to do it, that's probably, I know, let's say you want to pay, you are okay to pay the gas for your users' transactions if they do fill in a form or they, I know, watch some ads, or if you want to go into that direction. Or another situation, which I'm also actually familiar with, is the fact that you want to totally subsidize meta transactions, or you totally want to subsidize the gas cost for your transactions through meta transactions as an user acquisition cost, right? That means that you as a company or as a team are okay to pay gas for the transaction of your users, and you consider that that is part of the user acquisition cost. And this is Argent, which builds Ethereum wallets for Android and iPhone. They do that. They initially, at least at the time when I worked for them as a backend developer, they were subsidizing gas for all the users that were installing their apps and would create a smart contract wallet that they actually provided. And then that the users could do anything like transferring, even swapping tokens on Uniswap V1 at that time. And I was involved in actually writing the code for relay service that would take the transaction, pay for gas, and propagate it to the Ethereum network. And initially, I thought that it's no big deal, right? It's an easy task. You take the transaction, you decide the gas price that you want to set on the transaction, and you push it to the network, and that's it. You use a library to like Web3.js or Ethers, and then you're done. It's not that easy because there are many complications in there. So Ethereum, because of its sequential way of processing transactions on account, does not allow you, or you get into the situation where you cannot process transactions for one user just because the transaction for another user who sent earlier was not processed. And then you have to think of the way of scaling it, probably own multiple accounts that you send transactions from, because a relay server uses an EOA, an externally owned account, just as any human user. There is no other way to do this. And then there are different situations where you want to send a transaction. You do that, you pick a gas price, and that transaction is not accepted by the network. It's not mined. And what do? They'll have the options. You have to treat this situation like you resend it with the higher gas price. The question then is what gas price to use. Maybe at the moment there's a spike in gas prices. Maybe you should wait for longer, and it's difficult to program all these kind of different alternate cases. Yeah, so it's not as rough layers. So as in we do have two different options. So we can have meta transactions on our DApp in an easier way, in a centralized way. So that's the blue pill. And we can have them in a line with the Ethereum ethos in a decentralized way. And it's not necessarily such a big thing, because the user still holds the private key, and there's no problem of custody in there. So the user still holds the private key to the wallet, but your centralized relayer could go down, and that's basically a single point of failure problem. Or maybe a centralized relayer could ban some transactions based on users' API, users' IP address or users' Ethereum address, and that's where we get the problem of censorship. So in this presentation, we'll take a look at both sides. We'll take a look at first at how what are meta transactions, how they work in principle, and then we'll take a look at one centralized layer or centralized option and one decentralized option.
May I ask a question? Does the I don't know, the central layers have any vulnerabilities because it's centralized, except they can ban some addresses? Maybe someone can introduce malicious code or change the relayer to.
As long as you host that service, this comes down to this securing your web service, and the same security rules applies to any other web API or HTTP API. So yes, there are of course risks because someone can hack your web service, but
why someone would choose a centralized way instead of decentralized? Does it have any advantage?
Yeah, it's a bit easier, and we'll see why.
Okay.
Yeah, it's a bit easier, and the decentralized option that we'll talk about, Open GSN, is not that popular at the moment, but we'll get to that. So we'll talk about that too.
Okay, thank you.
No problem. Good. So let's jump into, okay, so what are meta transactions? Are there some kind of special transactions, or what do I need to do, or how can I identify a meta transaction on the Ethereum blockchain? And the thing is that I cannot. So basically, there is no native support for meta transactions in Ethereum or in the Ethereum virtual machine. So very much like ERC20s, there is no native support for tokens, right? You do have a cryptocurrency called ETH, and you have smart contracts, and they have built tokens based on a standard called ERC20, and that standard is basically what makes or simulates tokens or other types of cryptocurrency. The same goes for meta transactions. So meta transactions are normal transactions, regular transactions, and they contain the actual transaction which are sent by the user, right? So the relayer or the operator will take the user's transaction and wrap it inside of its own transaction, and that's why it's called meta transaction. This is the reason. And so in this case, a meta transaction, if it's sent by the relayer, it will go from the relayer address, it will go to a forwarder address, or let's say for now to the destination contract. We'll talk about the forwarder later. It has a gas limit, just as a regular transaction has a gas price, or in the EIP 1559 transaction, it has a max gas price and the max priority fee field, and then it has a value just as another transaction. And yeah, one thing to mention about the gas price: the gas price is usually determined by the relayer, right? Because you want to separate and to give this decision to the operator that sends the transaction. Other than that, everything that the user sends will be filled into the call data of the meta transaction. And now let's try and implement this. So there are different ways to do this. Either you do it in a custom way, and when I say meta transaction, it's just a concept. You can do it in any way possible. And there are people who initially started and developed this unwrapping of the original transaction in their contract together with all the logic, business logic of their contract, and doing things manually until a standard emerged. And that standard, which is called the EIP 2771, is basically defines the way meta transaction should look. And it's all in all, it makes easier for developers to add support of meta transactions to their contracts. So this is one benefit of the standard. And then another benefit is that this is a standard way for a client to discover that your DApp has meta transaction support, right? So just as in case of tokens, if you implement ERC20 token or you use ERC20 standard, you it's easier for a wallet, for example, to discover the fact that your contract is actually a token or the contract of a token. And then that wallet can display the balance of whatever token that is and make transfers and so on. So the same thing in here as benefits. Good. So let's take a look at how it works. At least this is the way a normal centralized relay would work. So we have the transaction signer or the user. And we have the recipient contract or target contract. I'll refer to it with target contract too. Okay, so I want this transaction signed by the user to get to the recipient contract and to be processed without user paying for gas. What I'll do, I'll put a relayer in between the user and the contract. Now, my relayer can have an API or expose an API endpoint. Doesn't have to be necessarily in the format of JSON RPC API like Ethereum nodes do. It can be any type of HTTP API or whatever other way of you think is better for your relayer to transport information from the user's browser to its service. And then this relayer will take the information that the user sends. It will probably run some validations first to know if it wants to pass the transaction further, and then it would take the gas price from the network and it will create or it will wrap all the parameters sent by the users plus the parameters that that it considers to be important, like and of course the gas price, and send it to a forwarder. And this forwarder is basically the component that I was telling you that people were kind of integrating in the early days in their own contract. But in this standard in EIP 2771, they have decided to separate this concern and put the forwarder as a separate contract that would call directly the recipient contract or the target contract. And now, the only responsibility for this forwarder, also the standard, I don't think it states that, but the only or the most important responsibility is to verify the signature. You can use various forwarders that are implemented or implement your own. But when you deploy your contract, your target contract, you have to specify which forwarder you trust. Because what the forwarder will do, it will verify the signature of the user and attest the fact that the transaction or the forwarding request has been signed by the user. And then it will extract the data, the call data that is sent by the user, and it will append the user address at the end of the call data. So, and then it will create a direct call to the recipient contract, and it will include in the call data the two parts, right? So the original call data sent by the user or whatever relayer has constructed in there. So there's also a trust relationship between the user and the relayer. And it will also append the address of the user. And then the recipient contract would be able to extract the address of the user. What, as we know, recipient contracts or whatever smart contract cannot extract via msg.sender variable the address of the caller, or at least not in this case. And then we'll take a look at how it's implemented and how can it get to use this function, msg sender function, to get the sender address.
Can you explain a bit why message sender doesn't work like the normal way, and you have to use
Yeah, of
this
course.
function?
Yes. So I have a contract in here. Trusted forwarder is another contract. This is a web service, and this is the signer, let's say the browser. If I log, or if I use msg.sender variable in the recipient contract, which address will it display? Or which address will it fetch from msg.sender?
Depends if it's a call or a delegate call, but
Yeah,
probably a gas relay or gas relay or trusted forwarder.
okay. Yeah, the way they have decided to do this is a simple call. So that means that the msg.sender value will be the value of the trusted forwarder, correct?
Yes.
Yeah. And because in the delegate call, I'm not sure, but if you do a delegate call and you maintain the entire state of the contract on the trusted forwarder, I think you might get into some situations that are probably more complicated. I cannot explain why I didn't thought of this option, but anyway, they have decided that it's best to separate this signature verification into another contract that calls directly the recipient contract or the target contract. Yeah.
Okay.
So msg.sender variable will get the address of this one. And by the way, even if we didn't have this trusted forwarder, with msg.sender, we would have the address of the relayer, but we're interested in the address of the signer, because the signer is an EOA, this is a web service, and the blockchain only starts in here.
Yeah, so somehow the gas relayer is also an EOA.
Yeah,
And
exactly. Yes,
okay.
that's important. Guest layer is an EOA because so there is no other account type that you could use for guest layer.
Basically, the gas relay initialized the transaction, right?
Yeah.
Okay, so
Yes,
that's
exactly.
so the transaction signer is not the EOA. It can be just the gas relayer, just the gas relay.
Correct. The
Okay,
transaction signer of the transaction of the meta transaction. Yes. Of
okay,
the
got it.
transaction that gets to the trusted forwarder, and we'll take a look at the code. But it will also include the signature of the user. And let's take a look at the code. It will be a lot easier to understand. So if you want to make your smart contract meta transaction ready, you have to do two things, at least according to this standard. You have to extend an abstract contract in order to gain access and to MSG sender, and replace and refer to MSG sender with this function. And when you deploy the contract, you need to specify which forwarder you trust. And why they called it specifically trusted forwarder is because this is the smart contract that decides the address that is appended in here, or the user address value that is appended in here. So that means that they're aware of how the trusted forwarder contract is implemented, to know its source code and all the other all other things that are required to trust it.
Yeah,
Okay,
so
so
probably if the web service, the gas relay, would try to use another forwarder, is impossible because this
yeah,
trusted forwarder is implemented in the main contract.
exactly. That's another thing. Exactly correct. So if I want to somehow hack this contract and do it through another forwarder, that would probably tamper this address, the user's address, then I would get into the situation where the recipient contract would reject the trusted forwarder, would reject the new forwarder or the forwarder that is not a good actor, let's say. And now let's take a look at the code. It's a very simple contract. There's not much in here. So as I said, you have to extend this ERC2771 context, or in case of Open GSN, it's called ERC2771 recipient. And here is the function, the MSG sender function. So what it does, if it first checks if the msg.sender is the variable, is the trusted forwarder. So it first checks that the call comes from this trusted forwarder, and then if it does, it will grab the last 20 bytes from the call data. That's what's happening here, and it will return this as the return value for the function. In case and the same goes for the call data. If you need it in your contract and you want to use it, so you would not use msg.data, you'll use this function, and this will again check that the call comes from the trusted forwarder, and it will take the entire msg data that comes from the trusted forwarder except the last 20 bytes, which is the length of the sender address. And of course, we also have the situation where you want your meta transaction ready contract to accept normal transactions. So probably in some cases, you do not want to limit your users from paying for gas themselves, for the users that want to do that. So you would allow users to interact directly with the recipient contract too, in order to have more flexibility. Okay, and what happens in this case, instead of going through this if branch, it will go in the else branch, which basically means that that this code did not recognize a trusted forwarder, and it will go on the default way of getting the MSG sender. It's a bit confusing that they still use a function in here, but if we take a look at the context, smart contract, this function actually returns msg.sender. It's probably just the way they decided to do this. So let's take a look in the tools. Yeah. So the context abstract contract will return the msg.sender. And they probably did it like that because they wanted to have a default value. Otherwise, they could have defined this as an interface, or anyway, probably other design reasons that I'm not aware of.
Can you go back to the last contract, please?
Sure.
So on the line 29, so it is removing the address of who? Of the EOA or the
Yeah.
forwarder?
So
I don't understand which message sender they replace?
Yeah, so it does not replace it. It takes the last 20 bytes of the call data. As we mentioned here, the call data in this case will contain the original call data plus the address of the sender. So everything that this function does, it's interested in getting the address of the user, and that's encoded in the last 20 bytes of the call data.
Okay,
Don't
understood.
ask me with the shift right operators. I don't know exactly.
Yeah,
uh,
it's so this is why it must be trusted, probably because as I observe, you
mhm.
can manipulate uh, what data you want from the transaction.
Yeah, exactly. So the trusted forwarder would add this last 20 bytes in the call
Mhm.
data. So you need to trust it.
So basically, you in Trust Forward can modify everything you want from that transaction.
Yeah,
That's crazy.
yeah, correct. Yes, but in the end, why would you tamper with it if you are the contract that would accept transactions from it? Yeah, you can think of different scenarios, but theoretically, a user should be very aware with what it interacts, what it signs, what gas layer it uses, and even the contracts that it interacts with. Yes.
Yes, nice.
Yeah. So not necessarily easy for new users, huh?
Yeah,
Okay.
nothing is easy in Web3.
Yeah, so they have to trust the more experienced users. Okay, and let's take a look at the implementation of the trusted forwarder. So this one, so a very small or very short implementation. So there is a minimal forwarder contract that is made available by OpenZeppelin. It expose an execute function. It's not actually send and verify, it's an execute function. And this execute function will first verify the signature, right? So it verifies the signature of the user. Otherwise, it doesn't make sense to proceed. And when it verifies the signature, it when it extracts the signer from the signature, it will check that the signer is actually the address of the that is specified by the request. And the forward request looks like this. So very much like a normal Ethereum transaction. There is a from address, there is a to address, value, guess, nonce, and data, call data. And what this means is that at this point, I already have the from address of the signer or of the user, the to address of the target contract, the value, if there is a value that needs to be sent, the gas limit, and the data. The nonce is managed by the forwarder. So the second thing that the forwarder has to check is the fact that the nonce has not been reused. This is a very important thing. So what this basically means is that the requested or that actually I said that the nonce is determined by the forwarder, but that's not true. The forwarder only stores the used nonces, and in this case it will check that the nonce that comes from the request is the same as the nonce that is currently available for the given signer address. And the reason to do that is to make sure that you do not repeat the transaction. So imagine that I would enable meta transactions on my token contract, and I would allow the user to send gasless transactions to make a transfer. Let's say it would transfer 5,000 tokens to another address. And then the relayer can take this and rerun it again. And that would be basically basically a replay. This is the reason why we have a nonce that is constantly incremented for each signer address. And okay, guys, give me a second. I'm back. Okay, so I'm back. So where we can you hear me?
Yeah, we can hear you.
Hello. Yeah. So the minimal forwarder, I'm not sure why they call it minimal, because it kind of has the most important features. So
One
it will
thing I
go
would
ahead.
like to ask. So if the data have the last 20 bytes have the address, why is necessary if we have that from transaction?
Mm-hmm.
I
Why it's necessary to have the from in the
yeah,
in here?
exactly.
Okay, good question. I don't know,
Okay.
because okay, let's see why. Um, okay, so I know why. that was the second. So it caught me there. The forwarder will get the forward request that contains the to address, right? And then it will take the from address, and it will take the from address and append it to the to the to the call data. So
Oh, I understand.
this
Okay.
address is not provided by some other means than the forward request.
Yeah. So basically, the call data always have the selector and the function, the parameters of the function, and they add to the call data the address, so they can manipulate the address on the smart contract. I
Yeah.
think this is how it works. Nice.
Okay. So that was the minimal forwarder. Let's take a look at an actual transaction. Okay, so this is the transaction as it is executed. This is the execute transaction that is implemented by let me from here. So this is a relayer that goes and executes whatever transactions with the forwarder, and this is the forwarder address, right? So this is the minimal forwarder. And because this is an external call, you can see the entire effect of this transaction in here. You don't have to go deeper into the target contract. So in this meta transaction, this level, the user, in this case, the end user has minted ERC721 token with ID 11, whatever this token is. And if you take a look at the call data, so this is the call data as we talked about in here. In the forwarder contract, right? So, and here's the information. We have the request from that the forwarder receives, the request, or basically this is the user address that will be appended by the forwarder during its call to the target contract at the end of the call data. Then we have the to address, which is the whatever NFT contract this one is, some mint staking, whatever. And then we have other information like that we saw in that struct, like value, gas, the nonce, and the call data as sent by the user together with the user signature. So this is basically the transaction that we see happening in here. right? Good. Questions so far? So is it clear how the transaction is forwarded here?
Yeah, at least for me, it's clear.
Cool. So the destination contract will receive this this data plus the from address at the end. These 20 bytes at the end. It will be appended to the end of the data as it comes from the user. And it will, of course, check. Good. Now, we said that we'll talk about two options, centralized layers and decentralized ones. So centralized layers, one of the centralized solutions is offered by Open Zeppelin through their Autotask mechanism. But so how it works is basically the sequence diagram is very similar to what I showed you in this standard, except there are two components. And that's just because of the internal function and the internal structure of Open Zeppelin infrastructure. When it so it leverages its Autotask components, and it creates a new component, which is the actual relayer or that the Autotask will interact with. But we can see these two as one component. And again, just as in the other diagram, the client signs the transactions, sends it on a post request to Autotask to Open Zeppelin, and then Open Zeppelin verifies it. It first does a pre-check on the forwarder, and then it goes and executes it. And then it gets to the target contract that verifies the trusted forwarder, executes its logic, and then the execution ends. And that's about it, except the fact that this request is not synchronous. So this is not a synchronous request. So probably after this verification, or even faster than that, the client will receive a transaction request, and then it can listen or it can poll for results for the transaction ID. And let's take a look at the dashboard. So here I have a relayer, which is this component in Open Zeppelin. So I'm on the Open Zeppelin Defender dashboard. And this relayer has its EOA address, which is filled with 1.96 Matic in here. And this balance of Matic will be used to send meta transactions or to pay gas on behalf of the users. And then this relayer is connected to an Autotask, which is this component on the diagram. I don't have successful items in my run history. I'm sure that I had at least 2 transactions. I think they are not displaying the entire history of the transaction, or they clear the cache from time to time. So the Autotask will be called with, you would send the transaction to this URL, and then it will go through the entire process. So that's the Open Zeppelin relayer. It's pretty easy to integrate in your API, in your front end, and then they have pretty good documentation on how to integrate it. There's very much half-baked code that you can reuse, and it's the fastest way to have meta transactions for your DApp. So that's the centralized solution. And the decentralized solution is the actual topic of this talk, and it can be covered in this diagram. So this is the open gas station network architecture. This the reason why they did this entire architecture is that they wanted to have multiple relayers. So this is the decentralized part that they were, or this is the centralized part that they wanted to decentralize. So to allow the client and the DApp builder to use whatever relayer is registered on the network, and not just one layer, which is considered to be a centralized solution. Then to do that, they have separated the relay runners from the DApp developers. So the DApp developers would have to develop a paymaster contract. We'll take a quick look on this. And then the relayers' sole responsibility is to make sure that they have the relay running and they have enough uptime in there. And that's through this relay hub contract, they have created a trustless relationship between the relay server and the paymaster contract. Why? Because, for example, if I'm a relay server, I want to make sure that the DApp developer, through its paymaster contract, will refund me all the funds in the same transaction, all the funds that I have paid to deliver the client's meta transaction. So this is the most important architectural decision that they have took. And everything is coordinated through the relay hub. The paymaster contract would have a balance in here. So you as a DApp developer, besides creating the paymaster contract, you would have to also deposit Ether or Matic or whatever if blockchain use, you would have to deposit it to the relay hub contract. And then the relay server would make sure that that your DApp has enough balance so that it can send meta transactions, pay for gas, and then get refunded from that balance in here. Okay, so is it clear so far? So why Open GSN is implemented this way?
Yes, it is.
Yeah. So the blockchain side is in here. So all these components are in this side, and this is the web service side, and this is the front end or the client side. So as a developer, what you need to do if you want meta transactions with Open GSN, you have to make your recipient contract meta transaction compatible, which is that you have your recipient contract needs to extend that EIP 2771 abstract contract and register a trusted forwarder. You do not either deploy your own forwarder, or you can take a look at the list of forwarders that are made available on the website by OpenGSN. Let's take a look in here. So if I go to their docs, I will see that unfortunately they do not have Ethereum mainnet launched yet on OpenGSN 3. But if I go to Polygon, okay, so here's a forwarder that you can use, and it's kind of it has the status of the official forwarder that OpenGSN has deployed to Polygon mainnet. Then you also have the relay hub address. I'll talk about this in a moment. Okay, so we have the recipient contract, we have the forwarder. This recipient contract is knows about this forwarder in a trust relationship, and then you deploy your paymaster contract. You either create a custom paymaster contract or you use one, depends on what you want to do. So the paymaster contract basically contains the payment logic, and I'll explain some a reason. Or basically, here is the part of the programmability that I was referring to when we started the talk. Okay, so you have your paymaster contract, you deploy it, you register.
The payment contract, like, can it be a simple wallet that maybe approve the transaction. I mean, approve the maybe ERC20 transactions. So it just hold. It's like a cold wallet, and but the transactions can take the money from it.
Well, no, because we'll take a look at the how it's constructed.
Okay.
It needs to comply with two things, or at least besides the fact that the relay hub is forwarding the call to the forwarder and to the target contract, it also does a pre-call to the paymaster so that the paymaster can decide, do I want to take this transaction further to my DApp or not? And then it would do the execution and send the call to the target contract. And after the actual forward call, the relay hub will do a post relay call to the paymaster contract, just in case the paymaster needs to add some logic to before it completes the transaction. And this is the external transaction. This is the main transaction. So everything in here happens in one transaction. These are all internal ones. So the reason is that there is a pre-call and a post-call. Otherwise, I don't think there is a way to hook in some logic into this flow from an UA account.
Okay, understandable.
So you have the paymaster contract is deployed. You register it with the relay hub contract. You also say what forwarder you want to use together with your paymaster contract, and then you make a deposit so that the relay servers will be refunded for all the transactions that they send. And basically, you are ready with the blockchain part. You can theoretically, you can launch your DApp at this point in time. You don't have to worry about the relay server if you go with the relay servers that are provided by the network. And of course, you need to do the front-end work. And the front-end work is pretty easy if you use Open GSN's library, JavaScript library, which what it does, it has this relay provider, so very much like the Web3 provider that you use to interact with smart contracts. You use this relay provider that abstracts away all this detail. So, and the way it abstracts it is to the point that the client or your React code or Angular or whatever framework you use is not aware of the fact that it uses meta transactions to interact with the contract. It thinks that it's basically a normal transaction. So, and if you use ethers as a library, it looks, so to the front end, it looks like it interacts with normal contract object that is provided by ethers. So that proxy object that it interacts through. So that's why they have created this dotted line, because this is a nice abstraction that they hide behind this their OpenGSN relay provider. And this provider, of course, also take care behind the scenes to send a request to relay server and so on. Okay, and after you use the provider, you can also do the following thing. You can state that you have a preferred list of relay servers. So maybe you don't want to use the relay servers which charge fees for sending meta transactions, the relay servers that are by default registered with OpenGSN. And at the configuration level, this is not agnostic anymore. So you need to know the fact that you are configuring your client to work with a preferred list of relay servers. And in case of fallback, it will pick a relay server from the ones that are registered on the network. And that's what the diagram says in here. So they call it relay discovery. So they first check if your DApp is configured with a relay server that you run yourself, and this is recommended by them. So theoretically, it is recommended that you as a DApp developer run your own relay server, and the registered servers are in there only for fallback, so only for plan B, in case, I know, your relay server is out of service or whatever happened in there in the infrastructure. Okay, so that's about it on the way Open GSN works. Questions so far? Okay, if now, let's rush into actually running a meta transaction. So there is this. Okay, so the easiest way to test it is to go and take this repo, and this is a demo app that I have created on top of the entire Open GSN stack. And it's a very simple game. It's let me actually open the code. So this demo app only does the following. So this is the target contract or the recipient contract. All it does, it takes the address of the sender through the MSG sender function that we talked about, and it sets assigns the value of the address to the current holder, and then you can read the current holder value. So whoever runs this this function will see its address in here until next one who runs this or executes this function, and then the address just changes. So that's just a very simple demo contract. It's basically a setter contract. Okay, and let me start the app. So to have it on your laptop, you just don't want it in here. I want it on Firefox. So all you do, you clone that repo, you run yarn install, and then you run yarn start. And there you go, you'll have this gorgeously looking user interface with enough information for you to understand how Open GSN works from a technical standpoint, to actually get the feel of it. Okay, so my account is this one. I am currently connected with my, let me create another one. Okay, so my account is FFC. So I have Zeromatic in my wallet. Okay, the address of the CTF contract or the demo recipient contract, we took a look at the source code. Current flag holder is the value of that field that we took a look at. And then you have different information related to the gas station network infrastructure. You have the relay hub from have the relay hub. Where is it? Yeah. So that's the relay hub address. Then you have the paymaster address, and then you have the forwarder address. Right. So these are the three most important components. Okay, and it says that it has a relayer. We'll take a look at the relayers. Okay, so everything I need to do now as a user. So currently I'm here. I'll click the button. The provider will send the request to the relayer. It will verify that the paymaster contract can pay me whatever amount back, and then it will send, because it's an async call, it will send the meta transaction ID to the client address, and then it will post the make the actual call, the actual external call to send a meta transaction to the recipient contract. So everything happens in here. Everything I need to do as a client, I need to sign the transaction. Be aware what you're signing on the web with your wallet. And in this case, because the data is structured through EIP 712, MetaMask is also compatible with that. I can see all the information that I'm signing. So I'll see information related to the relayer, how much gas will be used, the paymaster address, the forwarder address, and so on. Okay, now I'll sign the transaction, and then this transaction will be sent to the relayer, and then we'll have our meta transaction posted, sent to the network. Let's see. Okay. I got an error. Or actually, no. I think it's a problem with this front end. But let's take a look. So if our paymaster contract is the first contract that my relayer interacts with, except I cannot. What's happening here? Cannot click it. Okay, so this is the paymaster contract. Oh no, sorry, my bad. We need to look at the relay hub. Okay, so this is my transaction 56 seconds ago. Okay, so this is the first thing that I see on the blockchain. So I'm looking at the transaction that is accepted by the relay hub contract. And if we take a look inside, we'll see, okay, it has been sent by this relayer. It goes to this forwarder, which is FC, no, not for the relay hub. And then let's take a look at the call data. We have the following. The three most important things are the relay request, which contain the address of the sender, address of the destination contract, whatever other parameters in here like gas and so on. So this is basically the actual request information, and then the relay data, which contains this is the address of the relayer. Zoom in a bit. This is the address of the forwarder, and that's about it. Okay, so yay, I have a transaction sent to Polygon. I didn't pay a dime. So of course I don't see the activity in MetaMask because MetaMask didn't add support for this. But with Zeromatic, I have sent a meta transaction to Open GSN, and it got to my contract. And now if I'll take a look, yeah, this is current flag holder, or the value has been updated, and this is my address.
That's cool. Nice.
Yeah, nice. Good. Okay, if you have questions, otherwise I'll go quickly through what you can do with Paymasters. So we have 20 more minutes, so give me 10 minutes and then we'll also allocate time for questions. Okay, so why would I need to implement a custom Paymaster contract? So in case of the demo app and the transaction that I just ran, you do not have any type of paying logic in there. So in this case, I have a simple Paymaster contract that doesn't do anything when it is called with a pre-relay call and then a post-relay call. It just accepts any address. Why would I want to do a different paymaster contract? Let's go back to the airdrop thing. So let's say you want to pay gas for a meta transaction that is targeting an airdrop claim, right? So I have some ERC20 token that has been airdrop, and I need to go and click claim on that and send the claim transaction, but I don't have any ETH in my wallet. I can go through a meta transaction, and my paymaster contract might agree to take my meta transaction to the airdrop contract in exchange for a share of the tokens that are returned by the relay hub contract, that are returned as part of the airdrop. And then the relay hub contract, how does it happen? The relay hub contract will go to paymaster contract and say, okay, so this is the post relay call. What do you want to do? And the paymaster contract will probably take a share of these tokens and send the rest of the tokens to the client. And what happens here? Let's say I get, I don't know, an airdrop of 1,000 tokens. The paymaster determines the fact that it will cost me 10 tokens to claim this without having ETH in my wallet. And the user, let's say in the ideal case, it sees that, okay, I'll receive 990 tokens if because that's the price that the paymaster has estimated, either going to Uniswap or whatever price oracle and so on. Much more simpler cases are when the user does not have ETH in its wallet, but it has, let's say, USDC or USDT or whatever stablecoin or DAI, and it does not, and it chooses to pay with DAI stablecoin instead of ETH. And in this case, the paymaster contract, let's take a look at the example that is actually implemented in here. Do you know this guy?
Yeah, it's here.
Okay, so so the token paymaster that will charge me as a user with some kind of ERC20 tokens instead of for sending the transaction, for paying ETH to send my meta transaction. So let's take a look at how it's implemented. So we have a pre-relate call, right? So what it does, as I said, the hub will first call the pre-relate call. And in this case, this implementation of the token paymaster does the following. It will take the preferred token that the user is willing to pay with. It will calculate the price or how many tokens value the max possible gas that would cost to send this transaction. So this is the value in ETH or in Wei. And then this function would calculate that, okay, so this payer would have to be charged with this amount of tokens, let's say 5 DAI instead of whatever amount of ETH needs to be used to send the transaction. Good. Now, this contract will transfer that amount from the user. It will take from the user, provided the fact that the user has approved, but that's another part. I won't go in there. So it will transfer the given amount, let's say 5 DAI, from the user's address to its own address. So that's the amount of 5 DAI token pre-charge. And then it says, okay, everything done. Then, so that was the pre-call. The relay hub goes and forwards the call and does whatever the contract in the amount of gas that was set as gas limit, and then that call finishes, and this does the post call. Relay hub does the post call. It executes the this post relay call internal. This is the part. What it wants to do, it wants to refund the user with whatever surplus that it had. So for example, maybe this call to the contract did not consume the actual gas, that it did not consume the entire amount of max possible gas, but let's say just three-fourths of it, 3/4 of it. And that then it will take and calculate the actual charge in ETH. Then it will calculate the token that it should be charged with. Let's say it was 370 DAI instead of the initially 5 DAI that were charged from the user. And it will calculate the refund, subtract here and get to 1.3 DAI, and it will refund the payer, which is basically transfer to the payer. And it also does a deposit proceeds to hub, which means in this case they chosen to convert the amount of tokens that those 3.7 tokens that they charge, they chosen to convert that to ETH. So the paymaster converts it to ETH, and then it would deposit in its own account on the Relay Hub. So the paymaster received the tokens, it goes to Uniswap and changes it to ETH and deposits back to Relay Hub so that it can continue serving meta transactions. Okay.
A short question about paymaster contract. You say that it should be custom. As I see, it's a basic procedure. You have to do the pre-relay call and the post-relay call, and it will refund the tokens to you and maybe the gas that it wasn't used. What should be custom? Looks like the standard to me.
It's not entirely custom. Custom meaning you can reuse one of the contracts and deploy it, meaning it's either you can take a look of already deployed contracts. I mean, custom as custom deployment. So you can take the exact same source code but you deploy your own paymaster contract. Why is that? Because the Relay Hub might be actually, I think you can go with already deployed paymaster contract instead of redeploying it yourself with the same source code or basically the same contract. But you need to check that the Relay Hub is okay. It's registered with the paymaster contract. It's already registered with the trusted forwarder. And yeah, now I realize why it is not a good idea, because let's say you find a paymaster contract that is deployed to a certain address, and you want to use that. If you reuse that, you also reuse the balance that the original developer has added for this paymaster contract. And if you reuse the same paymaster contract, even if you define correctly and configure correctly your client and provider and so on, you, together with the initial deployer, would have to share the balance that is deposited for this paymaster contract. I'm not fully aware, but I think this is also a restricted operation. Yeah, I don't think you can reuse it for.
I think the paymaster contract can be modified to hold maybe balances for each relay and just build one paymaster for each relay. As I don't like a bank. Each relay to have an account on the paymaster contract. Maybe for Ethereum is a good choice to not redeploy on contract. I'm just wondering.
Well, I'm not sure how you get through the shared balance situation with other developers. So if I have a DApp with everything set up by master and so on, and I have deposited the balance, and you have another DApp, and you want to reuse my paymaster contract exact deployment, you would basically stick your DApp in here, and people would be able to send meta transactions from my balance. So I think that there should be some kind of limitation in here. If not in the relay hub, then at least in the trust in the forwarder. I'm not sure exactly. We could. This is a bit more advanced, so I didn't look too much in detail at the relay hub contract. But I'm sure that there should be some ways to prevent someone from using the funds that you deposited for your DApp and fund meta transactions for their own DApp. So that's my longer answer. Okay, guys. Other questions related to the decentralized transactions?
Do you know any use cases, like maybe for gaming it's the best to have centralized relays?
To be honest, they are not very popular, or at least not as it seems in here. And by the way, Ethereum is not available. Ethereum mainnet, actually I told it, is not available on the last version of Open GSN, which is version 3. It's only available for version 2.5, so you can find the mainnet information here. Okay, but back to the question. I'm not sure. So we could take a look and see different let's take a look at the status page. So this is the status page of OpenGSN with the deployments on all the blockchains that it supports. So let's take a look at Polygon mainnet, and we can see information related to the relayer. So this is the relayer URL. If I click on this, I'll get this JSON that basically is the meta information related to the entire thing that is going to the entire infrastructure setup for this relayer. And then we have a status. We know that it charges 30%. So when this is an official relayer registered on the network. If you want to make profit, you can register your own relayer in here, and you can charge in fixed amount of GUI plus percentage of the gas cost if you want to, but you would also have to stake a given amount of tokens or native coins. So this relayer has a stake for a very long time of 1 Matic. In case it doesn't behave properly, it gets slashed and it will lose this amount. I'm not sure exactly how slashing works, but this is the principle. And then we have the address of, I think these are the addresses of the workers. Yep. So there is a main relayer and a worker relayer, which is the same source code, but with a switch flipped in the configuration. So these are the actual relayers. So if we take a look at Polygon, at least through the official relayers, there is not very much, lots of activity. So we have calls from time to time, and we can take a look at whatever contract has been called in here. So I think it's oh, this is the target contract. What's this? This is the actual capture the flag. I think that's actually my transaction.
This is a new product. Why is not used? I mean, I see the utility. I don't really understand what why people don't use it.
Yeah. Well, it's a very good and interesting idea. It seems that sometimes the market does not go into the direction of that the technical people thought of, or maybe I don't have enough information, because keep in mind that many there are lots of, so it's recommended for a DApp developer to run its own relayer. So I'm sure there are many relayers that we did not see. So we theoretically should look at the relay hub contract to understand where's the relay hub. Yeah. To understand, to see what addresses or what transactions are done. Not sure why. Relay hub. Manager owner. Oh, just curious. Yeah. Know why? Because version 3 has a relay manager that sits in front of a relay hub. They have complete. It's even more advanced. So let's take a look at the manager. No transactions here. Oh, that's weird. Or the address is not correct. I'm not exactly sure why.
I also tried the worker address. I'm curious. Maybe they made a mistake.
Probably this one.
No. Interesting.
Weird, because I just saw my transaction and they're going through this one, 434. So this is the relay call. This is the relayer. It goes to, this is the hub. Okay, so this is the hub for the correct address for hub. FCEE, just as we saw in the capture the flag game, FCEE. Okay. And these are so not very often, at least not on Polygon. So everything that's relay call is an actual meta transaction. Maybe it would make sense. I don't know. Let's think of other use cases. Maybe this case with airdrop would be nice and more applicable and popularize a decentralized network for sending meta transactions, like the one that you have an airdrop, you don't have any ETH and you don't have any ERC20 to pay with, and you just enable meta transactions for that contract, and then you allow people to claim their rewards without having any ETH on the wallet. It depends. It's also lots of, let's say, marketing or product market fit situation.
Yeah,
Or
in this
you.
moment, I think the only use case I see only when you have something to claim, like airdrop or gaming NFTs, or you have to claim something to pay with.
Yeah, that's an example. But another one. Imagine that I want to allow my users, and don't hate me for that, I want to allow my users to mint NFTs with credit card. And it's possible to do it in a decentralized way with Open GSN. The credit card payment is just the way that the user would compensate for the gas that has been used to mint the NFT. And it's pretty much doable with some tweaking engineering in this area.
So you
So
basically get
probably with
you are paid out of the blockchain and you pay in the blockchain.
yeah. So So no. So you pay with a credit card in the pre-relay call. But no, I would need to think of it. But I feel like it's possible to be done.
Mm-hmm.
Okay, cool guys. So other questions? Okay, thank you very much. In this case, we'll wrap it up in here, and I'll see you in the next talk. I think we'll have the next talk in probably 3 or 4 weeks from now. And again, if you have an idea to do a presentation, and let's talk. And we're trying to gather as many speakers as possible. And again, I think it's the best way to learn something. For example, I didn't have any idea about how Open GSN works 3 or 4 weeks ago, and I have decided that okay, I want to study this. I'll do a talk, and then I had no choice other than to actually study well enough in order to be able to explain at least the most common questions. Cool. Thanks very much, and see you next time.
Thank you too for valuable information. It was a good presentation.
Yeah. See you guys. Bye bye.
Bye.
Bye.